Alright, so this video we're going to look at combinations. So let's go ahead and get started. So it says here that a combination of items occurs when items are selected from the same group, no item is used more than once, and the order of the items makes no difference. Alright, so this video is on combinations. I did a previous video for contemporary math on permutations. Well, permutations, the order matters. Combinations, the order doesn't matter. So you can make sure you watch the permutation video and watch this one. And then I have a separate video on my YouTube channel that all that video is the difference between combinations and permutations. So you might want to search for that one, and it goes in more detail about it. But so first, let's look at this. We've got an example, and all this example is, we're not calculating any combinations or permutations or anything. This problem here simply wants us to determine whether the problem is a permutation or a combination. All right. So the first one, it says 6 students are running for student government, president, vice president, and treasurer. Okay, so they're running for student government president, vice president, and treasurer. The student with the greatest number of votes becomes president, second highest votes becomes vice president, and third highest becomes treasurer. How many different outcomes are possible? Now, like I said, we're not going to calculate the outcomes. We'll do that in problems later on. But right now, we just want to know, is it a permutation or combination? All right, so we're out of the 6 students, we're choosing 3 of them. So we've got 6 and we're choosing 3. And the way that we choose these, does the order make a difference or not? Well, on this one, if we look at it, so we've got president, we've got vice president, and we've got treasurer. And we've got the 6 people down here. Let's just call them A, B, C, D, E, and F. All right. So if A gets the most number, so we get A, and then let's say we get B, and then we get C. All right. That's one way. Person A is president, person B is vice president, and person C is treasurer. Well, let's suppose that this is selected where C gets the most number of votes, and then B gets the second most number of votes, and then A is the third. Well, you can see that it's the same 3 people, but the order that the votes, were received, the number of votes received, was different. And now, instead of A being president, B being vice president, and C being treasurer, well, now C is president, B is vice president, and A is treasurer. That's a different combination. So in this one, the order made a difference, didn't it? See, in the first one, it was A, B, and then C as far as highest votes to lowest votes. In the other one, it was C, B, and then A, from most number of votes to lowest number of votes. All right? And it's a different outcome. The order made a difference. So this would be a permutation. All right? Now let's look at this one. 6 people are on the board of supervisors for your neighborhood park. A 3-person committee is needed to study the possibility of expanding the park. How many different committees could be formed from the 6 people? All right, so let's just look at this. Let's look at person A, B, C, D, E, and F again. All right, so I'm going to put people on the committee. So let's suppose I choose A, B, and then C and put them in a committee. Okay, put them on the committee. So let's say I make another selection. And okay, well, I'll tell you what, let's do it like this. Let's choose the three. Let's choose A, and then let's choose B, and then let's choose C. That's a committee there. Now, let's suppose I choose C, A, and then B, and put them on the committee. Well, did the order that I choose those people, did that make a difference? No, it didn't make a difference because, I mean, is that like, is a person a president or a vice president or a treasurer? No, they're just people on the committee. You see that? There's no ranking of, what position they are or anything like that. It's just these three people are on the committee. Okay, so in this case, the order didn't matter, so this is a combination. All right, so let's look at the next one. It says Baskin Robbins offers 31 different flavors of ice cream. One of its items is a bowl consisting of 3 scoops of ice cream, each a different flavor. How many such bowls are possible? All right, so let's suppose that we have a bowl here. Okay, and let's just say that we get a scoop of vanilla and put it in there. We get a scoop of chocolate and put it in there, and we get a scoop of strawberry and put it in there. And then you give the person their bowl. Okay, now would that make any difference if I did the bowl like this? If, say, I got a scoop of strawberry, then I got a scoop of, say, vanilla, and then I got a scoop of chocolate, and then you hand that person the bowl, it doesn't matter. Okay, this bowl is the same as this one. Okay, the order made no difference. So this one would be a combination. All right, so hopefully that clears some things up on the difference of a permutation and combination. And when you're doing these types of problems, doing the actual calculation of how many different ways it can be done, that's really the easiest thing to do. Okay, it's not difficult to calculate it. The most difficult thing with these problems, permutations and combinations, is deciding which one it is. Because, I mean, yeah, when you're doing your homework in the book and everything, I mean, you're in this section for permutations. So all those problems, they're going to be permutations probably. And then when you get to the section in your book on combinations, well, probably they're all going to be combinations. But I'll say this, the book I'm using, it does a section on permutations, and then the next section is combinations. So that section on combinations, it might have some permutations mixed in with it. And, and sometimes the directions will tell you use combinations, use permutations, but then sometimes the directions won't say anything. They'll just say, find the number of ways, and you've got to decide which one to use. All right. So just like with the formula for permutations, we've got a formula for combinations. So we've got combinations of n things taken r at a time. All right. So the number of possible combinations of r items are taken from n items is, and this is the notation, C n r, is n factorial over n minus r factorial times r factorial. All right. So for this one, the notation I used for combination, that's similar to the notation you use for permutation, except instead of a C, you've got a P. Now, another way that we can represent combination. See here in this, this is how they represent combination. This is combination N choose R. Another way that you can represent combinations is like this. This right here means combination N choose R. As far as the book I'm using, this is the only notation that I've noticed they use, but some books may use this notation. It means the same thing. All right, let's look at example 2. It says a 3-person committee is needed to study ways of improving public transportation. How many committees could be formed from the 8 people on the board? All right. So we know that this is a combination because we've got 8 people and we're just choosing 3 of them and say, okay, y'all are on the committee. We're not saying you're the president, you're the vice president, you're the secretary, you're the treasurer, or anything like that. We're just saying, okay, I'm going to pick you, and you. Y'all are on the committee. So the order makes no difference. So to solve this, we've got combination N choose R. Well, how many people do we have total? Well, we've got 8 people. And how many of them are we choosing? We're choosing 3 of them. All right. And so if we plug this into the formula, that's 8 factorial over 8 minus 3 factorial times 3 factorial. All right. So now the factorial notation, I went over that in the permutation video. Just real quick, if you have something say like 4 factorial, that's just 4 times 3 times 2 times 1, which is 24. That's what factorial means. It's you start with whatever this number is, and it's that number times all the way down to 1. So 5 factorial, that would be 5 times 4 times 3 times 2 times 1. All right. All right. So now what you can do here is you can work this out. That's 8 factorial over 5 factorial times 3 factorial. And so, I mean, when you simplify that out, that's 8 times 7 times 6 times 5 factorial over 5 factorial. See, the reason I did that is these 5 factorials will cancel. And then the 3 factorial, I write that as 3 times 2 times 1. Well, you can see 3 times 2, that's 6. So that 6 and that 6 is going to cancel out, and you're left with 56. Now, the reason that I'm not going into a lot of detail about calculating this by hand is because calculators will do this. You'll need to look for the button. Looks like, it looks like this on your calculator. You'll either have a button on your calculator that looks like this, or this will be above a button where you have to hit the second function key on your calculator to get to it. Or like on my calculator, there's a PRB button you got to hit to get to it. And on some, I think there's like a math button on the big TI calculators. You hit math and then scroll over to PRB. Okay, I'm not going to go over how to do it on the calculator because, everybody's got different calculators. And so just check out your manual. Just get your manual, or some of you got there's a little card in the cover of your calculator. Look at that. Those usually show you how to do type in the combinations and permutations and the factorials. But yeah, just this, you get this right here, then you can just punch this into your calculator and just go straight to the 56. Now, some of you, your teacher may want you to do it out by hand, and that's fine. You can do that easily too. All right, let's look at example 3. It says, in poker, a person is dealt 5 cards. from a standard 52 card deck? How many different 5-card poker hands are possible? All right, so this is a combination because when somebody deals you the cards, does it matter what order you get the cards in? No, because I mean, a lot of times when we get our cards, when they deal us the cards, first thing we usually do is we'll, maybe put them in order from highest to lowest value, right? Or sometimes if we have a pair, we'll put those two together. If we have 3 of a kind, we'll put those 3 together, something like that. Okay, so the order that you get the cards, that makes no difference. So in other words, if somebody dealt you a 2, a 3, a 2, a 5, and a 2, versus if somebody dealt you a 5, a 2, a 2, a 3, and a 2. These are the same hands. You've got 3 of a kind. You got 3 2s. See, the order that you received them didn't matter. So this is combination. And how many cards do we have? Well, there's 52 cards. So that's 52. And how many are you choosing? Well, you're choosing 5. All right. So I'll go ahead and put it into the formula. So that's 52 factorial over 52 minus 5 factorial times 5 factorial. And what does that equal? Well, punch that into your calculator, and that's going to be 2,598,960. And that's the number of different poker hands possible. Okay? All right, let's look at this example 4 here. It says, in January 2017, the U.S. Senate consisted of 46 Democrats, 52 Republicans, and 2 independents. How many distinct 5-person committees can be formed if each committee must have 2 Democrats and 3 Republicans? All right. So let's look at that. So it involves choosing 2 Democrats and 3 Republicans. So how many ways can we choose the 2 Democrats and how many ways can we choose the 3 Republicans? All right. So first, let's look at choosing the Democrats. All right. Now, the order that I choose those 2 Democrats, does that make a difference? Well, no, it makes no difference the order that I choose the Democrats, because I'm just picking this person, say, okay, you go on the committee. Doesn't matter if I pick person A first and person B second, or person B first and person A second. That makes no difference, because I'm just picking the 2 and say, okay, you're on the committee. They're not going to have any kind of title like president or secretary or anything like that. So for the Democrats, that is combination, and there is 46 Democrats. And how many am I choosing? I'm choosing 2 of them. Okay? So this is equal to 46 factorial over 46 minus 2 factorial times 2 factorial. All I'm doing is taking this and I'm plugging it in to the formula here. That's all I'm doing. Okay. See, I know the 46, that's N, and the 2 is R. And then and like I said, if your teacher wants you to write this down, write it down. If your teacher doesn't, just says, okay, you can punch that in your calculator, you don't need to write this down. Okay? As far as me, I could care less if you write it down. You get this, I'm happy. Punch it in your calculator, give me the answer. All right, so 46, combination 46, choose 2. That is 1,035. All right. Now I need to get the Republicans. All right, so how many ways can I choose the Republicans? Well, there's what? There's 52 Republicans, and I'm choosing 3 of them. All right, so this is what? 52 factorial over 52 minus 3 factorial times 3 factorial. And that ends up giving you 22,100. All right. So what they were asking us to do is they want to know how many distinct 5-person committees can be formed if each committee must have 2 Democrats and 3 Republicans. So the total number of committees that could be formed would be the number of ways that we can choose the Democrats times the number of ways that we could choose the Republicans. I wrote that wrong, didn't I? No, that's not 42, that's 46. Okay? And see, that's exactly what we did here. We calculated it here and here, so we just multiply the 2 together. 1,035 times 22,100, and that is equal to 22,873,500, and that's the number of ways. All right, so let's see. Oh, and it looks like that's the last one. So see, this stuff here, it's not bad at all. The combinations, permutations, it's not bad. Like I said, the most difficult part about this is deciding which one it is. Okay, and like I told you earlier in the video, if you want to see more detail on that, go search my channel for differences between combinations and permutations. I go into a lot more detail than I do in this video. All right, so hope this helped. Check out my other videos. Give me a like, share, and subscribe, and thanks for watching.